Okay, so today we will learn about binary search, but let's first understand it by using it by seeing the demonstration during using diagrams. And for this, I will use a very great website called Programmers because they represent it and they give the theory part quite simply. Okay, so they have given two methods, recursive method and iterative method, but we will be going with the iterative method because a recursive method involves recursion and I don't want to create any confusions here. So we have got a array here. This is our original array, and here we need to search an element. Okay, but before going to the searching part, one thing you notice about this array, that this array is sorted. Yeah, this array is sorted like, and so it comes to us that binary search only works on sorted array, but using that, but still it's faster than the linear search, because in linear search you need to search whole array, but in binary search you need to search only one half of the array, and it's much faster. Okay, I will tell you the working of it. So here in this array we set one lower bound and one higher bound. Don't understand that this lower bound is 3 and the higher bound is 9. No, this is not correct. The lower bound is the first index or the lower index in the index of 3, and the higher bound is here is 6, because the indexes are 0, 1, 2, 3, 4, 5 and 6. Okay, that's the indexes. So the upper bound is 6 and the lower bound is 0. Now for the next step is to find the mid element. Now how we will find the mid element? We will say lower bound plus upper bound divided by 2. So we will automatically get 3 here. Now which is the third element? 0, 1, 2, 3. So this is the fourth element here, which is the middle element. As you could see, it has 3 elements this side, it has 3 elements this side. Even if it has 2 elements this side and 3 elements this side, it will work. The binary search will work even if it's not like this symmetrical. There is a mid element and equal amount of elements on both sides. Even if it's not there, the binary search method will work. Suppose there are only like 0, 1, 2, 3, 4, 5. There are 7 elements in this array, and since that's why we are getting a proper middle element. Suppose there were 6 elements in the array, then we would have got 0 plus the last index would have been 5. So 0 plus 5 divided by 2, it would have given me 2.5, and an integer that would result to 5. So this will give me, this will be the middle element. Okay, now let's move further. So after we attain the middle element, one thing we could notice that on one side of the middle element we have all the numbers smaller than this, and other side of the middle element we have all the numbers greater than this. Okay, now what we will do, suppose we want to search x is equal to 4. Now we will check whether the number we are searching is less than 6 or greater than 6. If it's greater, or it's equal to 6. If it's equal to 6, then our work is done. Then we will just return the position of this middle element, which is 6. We will return its position. So the index will be 3 and the position will be 4. This will be returned. Now if it's not equal, then we will see if it's greater than 6, then we will search on this half, and if it's less than 6, we will search on this half. So instead of searching the whole array like we do in the linear search method, we only need to search one half of the array. Okay, we only need to search one half of the array. Now as you could see there, if suppose they have taken the example of x is equal to 4, so which will not come in this condition, x is greater than mid. So this will not come in this condition. It will come in the condition, suppose x is the else condition, the else of this part. So x is less than mid. Okay, x is less than mid, then what we will do, we will say that it is observed in this part. So what we will do, the lower and the higher bound, we will set the higher bound to 1 less than the mid element. So all the elements between lower and the higher bound will be searched. So low to high. So this higher bound was here initially. Now we have brought it to 1 less than mid. Now only this part will get searched. Okay. Now if the element was not on this side, but suppose we wanted to search for 9, then what we would have done, so this was higher bound, it will remain as it is. As you could see in the previous diagram here, the higher bound was here. Now what we will do, the lower bound will come 1 increment one from mid, and the lower bound, that will be the position of the lower bound. So now this is our array which we will be targeting to search when the number to be searched is greater than 6 or the greater than the middle element. Okay, so now I hope this was clear, and how binary search helps us to solve the problem faster, as we are searching only one half of the array instead of searching the whole array. Okay, now let's move on to the code. Okay, so after understanding the coding part, now I will be explaining the no, I mean, after understanding the theory part, now I will be explaining the coding part. So here I have already, as you could see, I have taken the number of elements from the user, and I have defined an array with that size. And according to that size, I will be taking the array elements. So this part I have had, this part is traversing, which I have already explained. And now the thing comes that we will use, now we will specify the lower bound and the upper bound. So we take two variables, int lower and mm, is higher. Okay. So let's say that the lower bound is the first element. So lower bound is the first index, which is 0, and the higher bound is the last index. Now suppose if the size of the array is 5. Suppose if the size of the array is 5, what's the last index? We know it's 4. So therefore, if the size of the array is n, then the last index is obviously n minus 1. Okay. So yeah, that's it. So I will say higher is equal to n minus 1. That's great. Okay. Now, if you hit Control S on Replit, it automatically formats everything. Now, the condition for why till how much time we will repeat the things inside binary search technique, it will be while lower is less than higher. So just remember this condition. I will explain about this logic earlier, or you can figure it out. Just check it whether you can figure it out. It's quite easy when lower is less than higher. So as just remember it this like this, that lower should always be less than higher. So while everything is all right, like lower is less than higher, we will run the conditions. Okay, and then inside it we will specify mid. So let's me define mid here. Int mid. Now why I specified mid inside this while loop, because as you know, as you saw in the theory part, the lower and the higher value, the value of the variable lower and the value of the variable higher, will always be changing. So what will happen is that the value of mid will also be changing. Suppose if we initially suppose we have an array of 5 elements, right? Let's say, wait, let's say we have this array here, 1 2 3 4 5, 1 2 3 4 5. So for now this is the middle element. Okay, let's make it 7, it will be easy for me to explain. So this is the middle element, which is the fourth element. Okay, now suppose the element, after checking the element to be searched, is present in this half of the array. So this will be the lower bound and this will be the upper bound. Now the middle element, which was initially this, for this particular half of the array it will be this. So the middle element is also updating. Okay, so that's why middle element is inside this while loop, as the loop will again run after the updation of lower and high, the middle will also update. So what's the formula for calculating the middle element? That will be lower plus higher, okay, divided by 2. Okay, that's great. Now next thing what I will do, I will check with the conditions. If, now let me define a variable here also, like position. Easier, it will be easy for you to understand position. Okay. If mid is equal to ns, so I have not taken ns from the user, printf enter the number to be searched. It's recording now. Yeah. So I had some mic issues. Enter the number to be searched. We'll say like this. Let's change the lines. I messed with my keyboard a bit. Excuse me for that. Yeah. Scanf %d say and %ns. Okay. So I will just define ns here, int ns. Okay. This will do. So if mid is equal to ns, what I will do, I will say position is equal to mid. Just enclose it within curly braces. Give break if else if mid is greater, or we can say ns is less than mid. That's how we will remember. If ns is less than mid, then what will happen? Then the upper bound means it's the number is present in the first half of the array if it's sorted in ascending order. First half of the array, it's present in the first half of the array. Then what we will do is that we will bring the upper bound one less than mid. We will bring the upper bound one less than mid. Refer to the theory part of the video. It will be easy. So we'll say upper bound, which is higher, is mid minus 1. Okay, so now our array is restricted to only the first half. The first half which contains only the numbers which are less than the middle element. Okay, now else what will be the condition? The number is greater than the middle element. Okay, then we will say then the lower part, the lower bound will become the then we will search on the second half of the array. So the lower bound will become mid plus 1. Okay, so now our array is restricted to the upper bound of the upper means the second half of the array. Okay, now it's done. While loop, and then I will say break here. I did. Let's try printing it. Now after coming out of the while loop, we will say now one more thing I will have to do. I will initialize this position with -1. Okay. If position is equal to -1, and if not found, else printf found at index %d position. I will print position %d. So for the index part, I will just print POS, and for the position part, I will say POS plus 1. Okay. So means the in the position is one more than the index. Suppose the 0th element is the first element for the user. Okay, that's why I did this. Enter the number of elements is, let's say the number of element is 5. Zoom here. Now I will have to enter the elements in sorted order, or you could write a function here to sort the elements, but that we will learn about later about sorting. So 4, 6, 8, 9 2. Okay, the number 2 we search, it should be, let's say, 3. Let's first check the not found condition. Okay, so 3 is getting founded. Okay, wait. Okay, so the mistake I was doing here, I was comparing it with the mid index. Instead, we have to compare it with the um, element present in that mid index. Okay, so I will do here ARR say mid. Okay, so now it should work. Run. Now everything is fine. Even that equal to sign was not a mistake. Okay, only this thing that we have to compare not with mid, with ARR of mid, because mid is an index, means the middle element. We have to access the um, element at that position. Mid is the position, okay, not the element. Okay, so let's say 9 17 60. I'm again writing ascending order only. 69 89. Now let's say 60. We say found at index to position 3. Now let's check the not found condition. 78. Oh, what I did, not 78 elements, I'm not going to type. Let's say 4 1 5 7 9. Let's search for 3. Not found. Okay, so it works. Thank you. And let's write the pseudo code here. Pseudo code dot txt. So we'll just clap and let's, the pseudo code will be here because I don't want you to bear me with that typing. So as you could see now, the binary search pseudocode is here. So here the binary search I have given as a function, so you can remove this function here. Okay, so now look at, see, the left bound is the lowest bound of the array, right is the highest bound of the array. You could say it as lower and you could say this as higher. Lower is set to 0 as according to a code, and higher is set to array size minus 1. Okay, that's all. And inside the while loop we are calculating middle every time. If this is equal to the middle, then we are giving it to position. No need to write about break. Until last, we are, after doing this, we are printing the middle element, which will be giving our position. Okay, now that's all for the binary search.